Hello everyone, we're in lesson 13 and it's time for some homework advice. For this homework, we are going to load a data set that we used earlier, the UFO data set, and then you will plot on a map where these UFO sightings occurred. And you'll be able to search for specifics in the UFO sightings, and also to make sure that we plot within the state correctly, we will use a data set that has the geographic centers of the state so that as you pick a state, it shows the middle of the state, not just, taking an educated guess of where the state should be. Okay. This project here, I would say, is a mid-level. This homework here is a great example of a mid-level final student project. It uses a lot of components. I will make sure to go through and list all the components that this project is using to give you an idea of that. And then we'll go ahead and implement almost all of it as part of this homework advice. Okay. That way you can sort of learn by example. So we'll start at the end, as we always do, showing you how it works. All right, here I am out in the solution, and I have my drop down of states as input, and I can input a state like New York, if I can find it. New York. And then I can say what I'm searching for. Let's do light. And then hit run interact, and it will grind through all of the UFO sightings in the data set, looking for ones that are in the state of New York, looking for ones where somebody said something about light in the summary, like I saw a bright light or a flashing light or something like that. And then it will plot each of those sightings on a map. And see what it did? It centered the map in New York State. It doesn't show me the map over here when all the pins are over here. That's important. So a lot of them have light in it. If you click on them, you'll see number of red lights flying slowly across the sky. Down here in Long Island, somebody said, bright orange light shines down in my bathroom window, then disappears. Okay? So just to show you that this works, I will pick New Jersey, and let's put in flashing. I'm looking for some flashing lights. And then it will recenter the map on New Jersey. And then there are pins here for triangle-shaped eye hovering over red, green lights flashing. See that? Or bright light flashing with lights hovering over. So this is a great example of what you might do for a final project, something similar to this, right? It's got a nice interaction. It's got a map. It's got a couple of data sets in there. Let's go through all the components that are used. Let's enumerate those, and then we'll go ahead and start working on the solution. All right, let's outline the components. We are using IPython Interact. We're using display. We're using a Folium map. We're using a center of each state data set. We're using a UFO data set. We're using pandas. We're using a drop-down in Interact. I mean, that's got to count for something. It's not easy. It's not trivial to build that drop-down, right? Right, and we're searching the data frame, right? So these can be considered techniques, right? Those are the components, I guess, but there's some of the techniques which also count for something. I got to say, using a drop-down, searching data, right? These are algorithmic techniques I need to figure out. I'm probably going to break this up into functions. I need to combine multiple data sets into a single data frame. So some of these techniques might be things that we didn't teach you that you figured out on your own. Like you might, like this might be the novel one. Like nobody taught you that. You figured out how to do that, right? I'm going to show you it, so it's no longer going to be novel. But, you know, something like that could be considered novel. So even though that this code solution, which is going to be very abridged, is going to be about 60 to 75 lines of code, I would consider this moderate complexity, which would put it in the B range. What do I mean by that? If you go and look at the criteria that we have for the project, you'll see that, you know, there's this guidelines as to whether or not it's, you know, possible to get, you know, best possible grade, B+, A+, C+. This one falls into this range. It excuse me, it does fall shy of the 100 line mark, but these are really just sort of guidelines for complexity. Okay, they're guidelines. In order to get this one into the A range, it would probably need close to double the lines of code as to what it's going to have. It would need closer to 150. So you might be wondering, well, how do I increase that complexity? Well, you need to think of other things that you can add to the project. Other things that you can add to the project to make it more complex. Okay, and that add features. Like one thing you might want to do is be able to save your settings. So if I was in this visualization here, maybe one of the things I can do is save all of my searches, okay, to a file. That would certainly add some complexity and add a lot more features, right? Then you're going to save search history to file, run an analysis of all searches. You know, that kind of stuff would really kick it up into the A range, no doubt, because then you might have a graph or chart of those searches and what kind of came up from there. Okay, so adding these additional components and techniques would definitely do it, and I'm sure you can find something in there that would be novel that you didn't use before. Now, what's going to add to the novelty of your own is you're not going to use this data set. You're going to find your own, right? Find your own. That's going to end up being novel, right? And you might also find some kind of API that you use, right? Or, you know, you might find API. You know, that would be novel. You might decide to not use Folium map, but instead maybe you're going to use Plotly maps. That would be novel. So there's lots of ways that you can improve the novelty of your project to get to those. It's not hard to get to the 3 novel things. It could even be a technique that you use that's novel. Okay, the way you go about finding or searching for things. Okay. All right. Anyway, let's get on with solving the problem. Basically, when you're doing this kind of interaction, there's a bunch of code that sets up all the data. So, right, we want to take our UFO sightings data and compile, if you will, we want to compile in that UFO sightings a big data set. Okay, if you remember that the UFO sightings, I don't know if you remember or not, but that UFO sightings data set has, you know, one file for each month. We want to compile all those months together into a single file. We want to do that all before this interact, right? So you want to build, there's a build up phase, and then there's let's get the inputs and see the output, right? But we don't want to do the build up phase within here because that's going to slow down the processing, and it's already slow enough. All right. So let's think of the inputs. We have several kinds of inputs here. We have user inputs, right? And we have non-user inputs, like things that come from APIs and from files and whatnot. So our non-user inputs are the UFO data and the center of each state data. And the user inputs are, pick a state and type in a search term. The non-user inputs generally occur before the interact. So we build up our non-user inputs and then we do our interact. So what are we going to output? We're going to output a map centered on chosen state with plots of each UFO sighting matching description. Okay. Now let's work through the algorithm. So again, the algorithm, if you think about this as a series of steps, we're going to build that UFO data set. Then we're going to build that geographic center data set. So that'll set up our data sets. Then we also have to build that list of states for the dropdown. I mean, that's a very specific step in our algorithm, but it's necessary to complete this this particular program. All right, so after we get that far, what are we gonna do? Well, we're gonna do something like this, right? We're gonna do input state choice and search term. Okay, filter UFO data set by state. Filter UFO data set by search. UFO data set, let's be specific. Is it comments, or I think it's summary, where they type up a summary of the UFO? I saw some blinking lights. Okay. By search term. All right, then we're going to have what we want to plot. So now we need to create map and center on state. Then for each item remaining in UFO dataset, I guess I should say for each item in filtered UFO dataset, we want to, what do we want to do? We want to make a marker, add to map. Then we want to display map. I think that's it. That's all of it. So that ends up being our algorithm. I mean, that's a pretty high level set of tasks. We're going to have to obviously write some functions here and make sure our functions work as we go about coding the solution. So let's get to it. And what I will do is I will write each function and test each function, and then put the final code in its own cell. I'm going to do it that way. This sort of prevents a student from just going to the end, seeing all the code and typing all the code in, and not, watching the whole video, which is important to really understanding what we're doing here. Okay, so let us first start with the UFO data set. Let's build that UFO data set. So I'm going to do these one at a time. Build UFO data set. Build UFO data set. Okay, I'll refactor it into a function. This is going to probably be a very long video. Let's go find that UFO data set, UFO sightings. So, that UFO sightings data set, there's 5 different CSV files. One for each, like this one is just January. This one is February. This one is March. Okay. So we want to combine these into a single data set. So we got a couple of things that we have to sort of figure out here. First of all, how do we load these? Pretty simple. Go get the raw, right? Where's the raw? Okay, that's what I want to load. So I'm going to copy that. Go back here. I'm going to keep all my imports up top. So I'm going to need pandas. Okay, let's go down here. UFO, data frame, PD read, CSV, that. Usually this works right out of the box if I could actually spell UFO right. There we go. Perfect. So there's problem one solved. But now, how do I go ahead and get, how do I get the February one? This one's January, right? This is the January UFO. So to get the February one, it's going to be, February UFO. And then this should be 2016, I don't know, 2? Let's see. 2016 02, 03, 04, 05. So you see what's different about this. 1, 2, 3, 4, 5, right? So I should be able to loop over this. Should be able to iterate over this, right? Don't repeat yourself. That's a mantra of coding. I don't want to make one variable January, one variable February, one variable March. That doesn't scale. What I want to do is say for I in range. I don't know how many of them are there. They start at 1 and they go to 5. So I go to 5, but I don't include 5, so that's 6, right? And then print I. 1, 2, 3, 4, 5. And then I take this here, and this is my UFO URL, and we're going to make an F string out of this baby. And then I replace this value with I. And then let's print the UFO URL. Right? 1, 2, 3, 4, 5. Let's try them out. 3. There you go. 5. There you go. This is important because the wrong way to do this, and this is why even though this has less lines of code, I would consider it a more complex solution, even though it doesn't hit, the 100 lines of code, because you're applying advanced techniques here. You're not manually getting each one of these into a variable, February, and then copying and pasting and doing March, right? You're not doing that. And then doing April. You're not doing that, and because you're not doing that, you should not be penalized because you have less lines of code. You're actually being efficient in your code writing here. All right, so a couple things we got to figure out. We can load these into data frames real easily, right? I could say UFO DF is PD read CSV UFO URL, but each time that's going to overwrite that data frame, right? If I come down here now and say UFO data frame, it's only going to have the last ones in there, 531. See that? Not good. What happened to January and February and March? They got overwritten. So I have to take what I do in my data frame and add it to the data frame. I have to append it to the data frame. So there is a function called append. Now, how do I know this? Again, I did a bunch of research and I figured it out. So this could be the novel thing that you figured out. Well, I figured out how to use this method that's in the pandas data frame that we didn't talk about in class, and I needed to use this method to accomplish my task. That's something you learned. You'll know you learned it because you did it. So a lot of you are concerned about your novel things. You're not going to know these novel things until you start coding and you realize you hit a wall and you need to get around the wall or over the wall. And the only way to get around or over the wall is to do some research, find a solution, and then apply said solution. Okay, so I wouldn't worry so much about having the novel stuff right now. That's going to come with time and coding. We get that. Okay. So let's see here. How are we going to do this? So I am going to make an empty data frame first. Let's make an empty data frame. Then let's take the UFO data frame and append to it PD read CSV UFO URL. So I'm going to get a data frame here and append it to the UFO data frame. Let's see if that works. All right, so I have January, and then way down here I have May. Now, one thing that I don't like about this solution is if you look, there are 2,000 rows, but there are only 340 indexes. That's because it keeps reusing the index. So there's actually a way, if you read this, if you read the directions here, this is going to cause us problems later. I know this because I've used pandas before. But if you read the directions here, you can see that it has a ignore index false. Right? If true, the resulting access will be labeled. Okay, so what we want to do is we do not want to ignore, we do want it to ignore that index, right? So we want to say ignore index true. And when we run this now, every row gets a unique value. So now it says 1939 and there's 1938 because it starts at 0. That's what we want. We want every row to have a unique value in the index, or else things like our filters aren't going to work right. So this is important, and we figured it out. So this code is good to go. I don't see, this is very efficient. I don't need to do this. So like, boom, look at how nice and tight that is. So now I want to write it as a function, right? Because I want my code to be modular. This is another way that you get a better grade is by using the things we applied in class, and one of them is user-defined functions. So def load UFO. Do all this. Return this. All right, let's try it. UFO df is load UFOs. Okay. Bingo. Looks great. So that's step 1 is done, right? I don't need this. I don't want to do that. It was just me testing. It's me just testing the function. But look at how tight that function is. That's efficient. If you can explain that, I'd be super happy. But again, you're going to iterate over each of these data sets. This way I can add more. If I put 10 in here, I just change this number to 10. There we go. All right, that's done. What's our next step? So we did this. Build the geographic center data set. Okay, so that was given to you up here. Right here. And this looks pretty easy. Let's build that. I'm going to make a cell for each of these. Build geo center data set. Okay. And what are we going to do here? We are going to say geodf is PD read CSV. Is it a CSV? What am I looking at here? Commas. Yep, CSV. This looks pretty simple to read in. Let's try it out. Okay, good. That's easy. I'm going to write this as a function too, again, for readability. No inputs. Return that. Okay, good. That's done. Build list of states for interact dropdown. Okay, so I've got my UFO data set. Let's make sure we call that. And I've got my UFO data frame. That's going to be my input. And I want to just get out the state. Okay, so we know that that's state. Oh, I got a key error. Let me just check this again. I know what I did wrong. I'm just helping you figure out what I did wrong. State. It's got a capital S in it. So, matters. I just want uniques out of here. There's a couple ways I could loop over this and build another list. Right? I could use value counts. Okay. I can see what kind of functions are available here. Right? So I can do a dir on this and say, hey, what kind of functions do you have that I can maybe use to help me get unique values out of this? Is there a unique or distinct or something? I don't see a distinct. See, any one of these you use that we didn't cover, that's a novel, right? Here's a unique. So now I need to get help on that, because I don't know how to use it. Okay, takes no arguments. All right, let's give it a whirl. Well, that would help if boy, it would really help if I. Okay, it's just it's an argument. What happened there? Unique. Tuple object is not callable. No uniques? That doesn't make a lot of sense. I see a lot of... Let's try another one, like city. Oh, that worked. All right. State. I'm getting nothing. That's weird. Is it because there's there's nons in there? Maybe I got to drop NA first? Oh, okay, yeah. All right, so let me explain what's going on here. This doesn't work because there are null values. So you have to first drop out the null values. And then from this, right, there's a series with no null values in it. And then from there, I can just get the uniques. And then this is a NumPy array, which I should just be able to convert that to a list like this. I should say, hey, make that a list. There you go. Perfect. Now, if this is like beyond your thinking, right, use a for loop. I can say states is an empty list, right? And then I can say for row in UFO data frame 2 records. If row state in states, if not in states, states append row state. Right? The classic, start with an empty list, loop over something. If something happens, add it to a list. right? Let's see what states looks like. There it is again. This one includes not a number, though. See that? So I'd have to get rid of that one. That's another approach that you can take. So how would I do that? You say UFO df.drop NA to records, right? And then now you get the states. There you go. Got to drop out the nulls. Okay. So there's another way to do it. So here's technique number one, one-liner. So you might say, well, Mike, I want to use this one because it's 4 lines of code. Again, the lines of code, it's a guideline. It's not a rule. Okay? You do something like this, that's pretty damn impressive, especially if you can tell us what it does. This is pretty damn impressive too, especially if you can tell us what it does. The issue is if you can't tell us what it does. Okay, we can't give you credit for it because you don't understand what you did. Okay. Here's another way that you can think about doing it. You could use a list comprehension. I don't know if you remember these guys, right? But a list comprehension uses a list to return a list, right? So one such list could be this for loop, right? So you could say states, and then you could say for row. Say I want row state for row in UFO df drop NA to records only if row state not in states. I know it's a little wacky. I don't know if you could do it that way. Yeah, see, I don't think it lets me do it. No field name state. Oh, wrong state. Okay, I don't know if this one works. Let's find out. Haha, it does not work. Okay, you can't do it this way because it doesn't know what's in states already. See? So this one doesn't work. I thought it might, but it's not going to. So there's only really 2 techniques that I can think of to do this. Pick one. If you don't understand this one, use this one, whatever. I'm going to pick number 1 because I wrote that one first. Okay, I'm going to leave them both here, but this is the function I'm going to write. Def get state list. And I'm going to pass in a data frame. Okay. It's a UFO data frame to be specific. Okay, I guess I could say that. It certainly does not have to match this. It doesn't have to. Okay, how's it going to work? Let's use this one. So I'm going to return, I know it's wacky, return this. Okay. Let's give it a shot. Get state list UFO data frame. There you go. I got to sort that, right? So I probably want to do something like this. I want to say states is that. Then I want to say states sort. Then I want to return states. It doesn't make sense to return it if it's not sorted. Now they're sorted. Now it's easier to find your state. All right. So that's number 3. So I'm going to call this approach 1, approach 2, and then this is actually the way I deciding to do it right there. Okay, so that is build a list of states for interact dropdown. Okay, input state choice and search term. Okay, I could do that. As a matter of fact, as I'm trying this out, I probably should be in the business of not doing inputs, but just picking, right? So let's just do this. Let's start to get down to brass tacks. You know, I'm just going to say UFO equals load UFOs. That's step 1. So this is going to be the final program here. Final program. Building it as I go. Geo is going to be, I'm going to call this centers. Centers is going to be read geo centers. And then states is going to be get state list from the UFO. And then let's just print states. Show you it's working. Load the UFOs, get the centers, and there's my states. Okay, the fourth step is to input state choice and search term. Okay, so let's try this out. Let's do state is going to be New York. We'll hard code this for now. That's my choice. And then my term, my search term is going to be lights. Let's do blinking. Okay. So I want to filter the pandas data frame, the UFO data frame on that. Okay. So that's what I need to do next. So I have UFO. It doesn't matter. I have UFO, right? There's my data frame. So now I need to filter this for only state where it matches this state. I'm going to copy these up here because I'm practicing up here, right? I want to make sure that my code works in this cell. So I want to say UFO state equals the state you chose, just New York. And now I need to just find blinking in here. Blinking in here. Okay, so this is going to be S UFO. I don't know if I'm going to do this. Or I don't know, UFO 1. UFO by state. Come up with a name for it. All right, so let's figure this out now. So how am I going to do this? I want to... Let's do this. Let's try. I'm just going to try with UFO. UFO. Okay, I want to do UFO summary. And I can't say equals blinking because none of them are going to equal blinking. That means they only said blinking. It's not the case. I want to find blinking in this, right? So this, again, could be a new thing that you learn, which is how to go about doing that. So we've seen this before in the lab. You need to make this into a string. And then when you use the string, you could use the string functions, right? So now I can say, why don't you try to find the search term in there, right? Now find, if you remember, let me just back up a minute here. There we go. There's a search term, right? So if the summary is this, the summary is this, and I'm searching for object, right? If I said summary find search, it's going to return 16. Why? Because when I search for object, it finds it right here, which is position 16 in the string. If you search for something that isn't there, you get back -1. So you know you found it when it's 0 or more. Okay, remember how find works. So this is actually another component that we didn't think about. We're using string find. See, there's a lot of components to your project. Some you're just not going to think of. So I'm going to say string find bigger than or equal to 0. That means I found it. Okay. Okay, these all say blinking. Blinking light. I don't know. This one's a little more. I can't see it all. Blinking light. Blinking object. Blinking moving. Okay. They all say blinking. So now we got to combine these. So I don't want to use UFO when I'm doing the summary. I want to use UFO by state. First, I want to search by state. Then I want to take that state and summarize it. And I want to say, you know, UFO filter. I don't know. I'll call it UFO filter because I don't know what the hell to call it. And then let's check that out, UFO filter. All right, something didn't work there. State New York. Search blinking. Is there no blinking in New York? There's got to be blinking in New York. There's blinking everywhere. I don't know. Let's put light. Okay, New York. Okay, so here's a great one. Oval. See, oval is right there? There's two ovals right there, and they're both in New York. So I'm going to put oval in here. There they are. I got them. So it does work. There's apparently no blinking in New York. Go figure. So you got to trust what you're doing and be able to figure this out. So let's write this as a function, right? Because this is good practice. So the inputs are going to be state and search. The output is going to be a data frame filtered, right? So we're going to call this def filter UFOs. And we're going to pass in the state and the search term. And what we're going to do is we're going to apply this. Oh, we also need to pass in the data frame. Right? So we need to take that UFO data frame, search it, filter it by state, then filter it by search. Then we'll have to return UFO filter. So again, I input the state, the search, and the data frame. And then I do that. And then I do this, right? This filters by state. This filters by search term. Then I return that. Okay, let's give it a shot. Let's give it a shot. Let's say filter UFOs, Connecticut, blinking. Hopefully there's blinking in Connecticut. Oh, I forgot the UFO data frame. There's no blinking in Connecticut? White. Okay. Apparently there's no blinking in Connecticut. How about blink? Nope. Blink. Let's try blink in California. Okay, there's some blinking. There we go. All right, so we know it works. Filter UFOs. So that's done. So, you know, this is going to be an input. This is going to be an input. And then we're going to say, I'm just going to call it filter. Filter equals, filter is a reserved word. See that? I'm going to call it filter UFO. Filter UFOs, state, search, UFO. How about we just call it FUFO? I love it. FUFO. Search is not defined. If I could spell search, it would be useful. Good. And then I need to change this blinking. There's no blinking. What was there? Orange? There was an orange in New York? Okay, there's a bunch of orange ones. Okay, good. All right. We are getting somewhere. I don't even know where we are. Okay, let's go back and look at our plan of attack. This is why plan of attack is so important. Because, see, I'm solving all the pieces. And then I'm writing my final program down here. But I always need to refer to my plan of attack. Create map and center on state. Okay. Create map. Okay, let's go back to our imports. I think it's just import folium. I might have to go look at the lab, but I think that's right. We're going to find out. All right, I got my map. Let's come down here. We need another cell. All right, now what am I supposed to do again? I'm supposed to make a map, right? So let's do this. UMap for UFO map. Folium. Is it map? I don't remember. That seemed to work. And then let's just UMap. All right. That's a huge map. There's obviously things I need to do to make this map look better, right? So again, I know exactly what to do. I'm just trying to help you with the process, right? So the next thing is you need to get help on this function so that you know how to manipulate it so that it, you know, zooms into the right spot and all that stuff, right? So let's do that. Help. Just going to go down here. Help folium map. Okay. I need a location, which is a list. And I need a minimum zoom and maximum zoom. And zoom start. Okay, that's going to zoom us in. So I need to give it a location, and that's going to be from here. So, right, I have, oh, what did I do? I had this one, where was it called here? Let's go down here. Read geocenters, right? I'm going to just copy this up here. So read geocenters. So then I need to get New York center. So let's comment these out. I need, like, let's suppose, you know, what am I searching for, right? State. Let's do PA for Pennsylvania. So now I need to get Pennsylvania out of here. That didn't work. It should show me Pennsylvania, right? All right, what am I doing wrong? Let's back it up a bit. These are things you're going to encounter. Oh, it's code, not state. It's code. See, I centered it. I searched it. That's code. Got to know what it's called. There we go. And I need to get out the latitude and longitude from this. Okay, but that's still a series, so I can ask for the first one in the series. Now that gives me a key error. I think I need to do that before. Maybe I need to do that here. No, that gives me a key error. Maybe I ask for the value. Series object has no attribute value. Value 0. I don't know what I'm doing. I'm doing this on purpose because this is what you're going to do, right? You're going to be like, I don't know what I'm doing. How do I get out this? I just want that number. So there's a couple ways you could do it. You could for loop over it and get it. You can convert it to a list and then get the first item in the list, right? I could say, all right, make a list out of this, you schnooker, and then give me the first item in the list. There we go. That gets it. Or I could figure out what what attribute I add to a series. Like if I say help PD series or dir and look through here, there's got to be a function that gets the value I want. There's a get. Maybe that's what I need. Get. There's iloc. I bet you I could use like iloc or something. One of these goofy. Let me try it without turning it to a list feels like cheating. Give me the first one. Oh, I gotta get rid of this. There we go. That does it. So iloc is a way to index this, and then just give me the first one. I bet you I can iloc here. Can probably do it this way, right? Yeah, that works too. Okay, this says give me one of them out. So I wonder if I can do them both now. I can say iloc latitude What is it? Can I get both of them out? It doesn't like that. Not at all. Oh, it does. I do get them out, but now they're series. That doesn't help me. So I am going to have to grab them individually, I think, which that's fine. So lat is this. Lawn is this. Lawn is this. That gets me their lat and lawn for Pennsylvania. Okay, and then I need to feed that into the map as a list. And I already forgot. Because when you're old like me, you forget. Location. Let's make it a list. Oh, that's centered over Pennsylvania, all right. It's just a little too far zoomed in. Okay, so that zoom level is not good. I don't know, 10? Let's try 12. It's not called zoom. Of course it's not called zoom, Mike. Ha! Oh, we're back to the help again. It never ends with the help. Zoom start. Gotta know what these named arguments are to call the functions right. Oh, now I forgot to show UMap. Too far in. 8. It's better. Maybe 6. It's too far out. 7 is the happy compromise. That's good. All right, let's change it to another state and see if it works. Here we go. Florida. Looking good. Let's try Texas, a big state. Ooh, see, Texas is monstrous. It gets most of it. I mean, you have to zoom it out. Let's try something a little in between, like Colorado. Yeah, it's good enough for Colorado. If it's good enough for Colorado, it's good enough for me. All right. So let's write this as a function now. Okay, what are we inputting here? We're inputting a state. We're outputting a map. Okay, so let's call this def get centered map. And we're going to input a state, and we're also going to need to input the geo data frame, which I called centers. And what are we going to do? We're going to do this. And then we're going to return UMap. But it's not called centers in here. In this function, it's not called centers. It's called GeoDF, right? You got to know your inputs. Or I could have called it centers, whatever. I'm just... Okay. So let's see if it works. I'm going to tear all this up. And then I'm going to come down here. And I'm going to actually do it. I'm going to go for the gusto. I'm going to do it right down here. I'm going to say UMap is get centered map. I pass in the state that I chose and then the centers. And let's show the UMap. I'm going to start to get fancy. So from IPython.display import display. And why not HTML? We know we're going to use that. Okay, let's get those imported. Let's come down here. Let's display that UMAP. I feel like the end is near. We're getting close. Boom! There we go. New York. Can change this to Kansas. And then we get Kansas. There we go. Okay. Like it. If I wanted to, I can even pass in the zoom level here. You watch this. I'm gonna make this function and say zoom start is 7, and then I'm going to say zoom start equals zoom start. Now I have a named argument in my function. So I can run this, and because I didn't give it a zoom start, it uses 7. But if I really wanted to, I could say zoom start 3, and it will do zoom start 3 instead, which is crazy. It's too far out. But you get it. I can override this now. It's a nice thing to do with your user-defined functions. All right. We're getting close to the end. Let's see where we're at now. We need to, for each item in the filtered data set, make a marker, add to map. Okay, we're getting close, but we're also getting to the point where we forgot a step. And I knew this when I did my algorithm, but I wanted to keep things real. So I'm going to loop. I'm going to keep my display map here. And what we're going to do is we're going to say for row in FUFO, right? This is the filtered UFO, 2 records. What do I need to do? Well, you might not remember, but let's take a look at FUFO. I need to go over each of these, and I need to put a pin that says red, orange, light at the location, but I don't have Latin long in here. You see that? Damn it. I don't have Latin long in here. I only have city and state. So I have to geocode each city-state to a Latin long. I need my geocode function. Let me go get it from before. We've done this a few times, so I'm just going to go grab it from a lab. Grabbed it from the last homework. Here's my geocode thing. So there's another component that I needed to do this, right? So this does my geocoding. I guess we could try it. Let's do this for row in FUFO to records. Let's say geo is going to be geocode. And then what do I need to do a geocode? I need a location, and I should probably build that location. I'm going to make an F string out of this baby. And I'm going to say row city. Is it city? I don't even know. Got to go down here and look. City and state. Row city. Row state. There we go. And let's geocode that location. And then let's print geo. All right, I never ran this cell. I knew that because it says geocode not defined. Okay, and a name error. Requests not defined. Ah, see? Now I gotta go back up here and import requests. Okay. Back down here. Okay, there's my one geocode, another geocode. Now maybe I want to get a little more specific with my geocode function. I don't want to have to dig through here. So let's make our geocode function return the very first value out of geodata, right? Because geodata is a list. Let's see if that's any better, a little cleaner maybe. Okay, so there's one place There's the other place. And these places have lats and longs now. I can find them right... Where is it? Lat and long right there. They have lat and long keys. If I really wanted to, I could just return those keys out of geocode too. I could say geocode lat, right? And then I can also return, I can be very prescriptive in what I return out of here. And then down here, instead of geocode, I can say lat long. And then let's just print lat long. I could do it this way. A lot of ways I could do it. Too many values to unpack. Oh, maybe I went too fast. Let's just try lat for now. Oh, you know what I did? I never ran this. Run this, then run that. It helps to rerun your function after you make it. There we go. So now it's geocoding just to lat and long. It'll clean up my main a little better. Okay, so now that I geocode, now I can do my pin, right? So I can say marker is a folium marker. And I forgot how to make one of these too, because, again, I'm old. So help folium marker. You can always open up a browser and dig it out on the docs on the website, but I prefer to do it this way. I'm in the zone here. I don't want to go out to the internet and then get out of the zone. So I need a location, which is a list of lat and long, latitude and longitude of marker, and then I need a pop-up. A pop-up is a string label for the marker. Okay, let's do that. So folium marker, location, it's got to be a list, lat, long, and then pop-up is going to be the rows. It's going to be the rows summary. Is that the key? I don't know. Maybe. And then let's do umap add child marker. So in the loop, I keep adding markers to the map, and then let's display the map. Oh, there we go. This one says red, orange, light. This one says red, orange. Okay. So I have it working. Now it's just a matter of adding the interact, and the game is over. All right, so let's get that going. Let's go back up here and do from IPython widgets import interact manual. And we'll go down here. Oh, I've never ran that though, right? Gotta run that. And we'll go down here and let's think through what we do. We do all this stuff, right? But it's at the endpoints, right? We can do all this, but then at the, this is a point of input. So now I need to say interact manual state equals states, search is nothing, and then I need to define a function that will execute when you click the button. So I'm going to call this draw map, and you pass in a state and a search as input, and then draw map is going to filter, get a centered map, loop over all the rows, geocode them, and then finally display the map. And this ends up being the final program. Let's see if it works here. Let's go to new. What did we do? We did Connecticut, and then we had blink. Did we have blink or white? I don't know. White. There's got to be some white lights in Connecticut. There's one white light in Connecticut, right there. The object was blue, white, and green. Okay, let's try something a little more interesting. Let's go to New York. And let's do orange. I think we did orange before. New York orange. Cranking away. It takes a while to process. There we go. Red, orange light moving very slowly above tree line with no sound. I saw a bright orange triangle. Okay. Saw a reddish fireball, orange, reddish, yellow. There you go. UFO on a map, data set, the whole thing, moderately sized project, you know, designed and crafted by yours truly, who knows what he's doing, and I did it in an hour. I don't expect you to do yours in an hour. It's probably going to take you 20 hours to do something like this. But this last homework assignment, I wanted it to be something very akin to what you might experience if you were to build out a project yourself. Total number of lines of code in this particular project is about 70, which again falls short, but the layer of sophistication involved in making this project work is really, really high. And because of that, that would be taken into consideration. A lot of components used in this particular project. Okay, that's a heap and helping homework advice for this week. I hope it was helpful. Goodbye now.